So PyData, welcome to PyData. I'm sure you have second day 2 of a very hands-on conference. I've heard PyData DC 16 is trending. So nice work there. Thanks for having me here, Brendan and Adam and the rest of the team. And Pi, as all of us know, is quite popular, powerful in two ways. Of course, from the math connotation, and the other connotation of life of Pi. So talk about a little of the both, but how the culture as well as the numbers make a big difference. Algorithms plus data is business. And today, if you're gonna think about, one of the earliest books that some of us have read was around how you use algorithms and create programs, right? Simple programs. That was the earliest title we hijacked here. But most business today is run on data, and financial services from Wall Street onwards have trended us towards algorithms. AdSense, one of the largest money-making machine out there, is 100% algorithms running on data. But these transformations do not come for simple, they come with people. Algorithms plus data plus people brings transformation. It's the teams that work together, that transform the entire companies, that make decisions using data, which brings transformation. Data-driven decision making actually needs a lot of courage. Oftentimes, they actually come up with completely counterintuitive analysis and conclusions, and people acting on them still needs a lot of courage. And that's kind of what part of the story of the keynote today will be, how we use visual intelligence to kind of try to demonstrate the interpretability of the analysis. Transformation with data and AI is right around the corner, which means change is coming in loads and loads of change. Time is our only non-renewable resource, and that's kind of what, obviously, brevity is kind of the wit that we've been asked to demonstrate, but time truly is the only non-renewable resource. I mean, everything else can be got back, including cash, but time will not be back for us. And so I go back to Bob, if your time for you is worth saving, now is the time to act and start moving towards using data and data science as part of your applications. Code is changing the world. Oftentimes, I run into people who come and ask for, how can I do X? What is the best way to do Y? How do I bring big change in the world? And there are only two really big ways to do that change. One is to be Deepak Chopra, which is not a mere feat. The other is to be a software engineer, because software actually is touching so many different spheres of life. It's no longer a programmer's part. Software is eating the world, which means we can actually now go and change different fields, whether it's agriculture, healthcare, insurance, cards, or just teaching, education, bringing care and serving communities is better done through software. And this community is an open source community. Python community is also a software movement. And kudos to NumFocus and others for supporting the vibrant community in Python world. But I think communities and software communities have now become to bring change to different vertical communities. And I think that's the bigger transformation happening in this space. Value has really shifted to asset-light platforms. What does that really mean? Well, Airbnb is more valuable than Hyatt and Hilton these days, right? And it has no physical assets to its capital. Same way as Uber is more valuable than Tesla. Right now, that changes our thinking about what is being more valued in terms of innovation. Your brand and your community is what you're building truly as a company, and you're defending your brand through real data products, using your data, forming alliances with your data. That what the data you have is some of the few, as a corporation, most companies have data today that is not available for Google or Facebook. That's the data you're using to build alliances with other companies with data and building simple, beautiful data products that can transform kind of your customer's experience. That customer experience is what you're truly making beautiful and more interactive to your core platform. And that's the core theme behind how vertical has become the true new horizontal. In many ways, as software is eating your vertical away, as people are digitizing your bigger business into lots of small micro businesses, you realize that software is a commodity because code is truly a commodity. Anything that is digitized will become free. So over time, the net base value of your business is going down. So the only way you can continue to increase the value is to bring in data products that are horizontals. Focus has shifted from internal to more of an external interactions. How do you build an ecosystem? How do you have a PyData conference, even though you're a Capital One as a company, and bringing community? This is an external interactions as opposed to just pure product focus or focus on yourself. How do you build meetups? How do you create grassroots movements around ideas of the core business? I think that's kind of and then spreading it to other horizontals. That's the core theme you're seeing. How do you give away resources? For example, this is Capital One is a conference center is a resource that has become available now for the Pi community, which is quite a dramatic difference from days before where you would have to lock in resources. How do you go from rule-based systems to pattern recognition systems? That's another core theme of AI. How do you go away? How do you look at outliers? How do you work on outliers as opposed to eliminating them? How do you not sample away the core theme behind your data? I think those are the kind of themes that you'll see with AI, where rebuilding of big monolithic applications from rule-based applications to pattern recognition-based applications using deep learning and machine learning. Microservices, not just monolithic apps. I think a large part of monolithic apps are going to be rebuilt in the next few years. And that's a tremendous, it's kind of, I would say, change that's bigger than even the Y2K kind of change, where people are going to rewrite a ton of traditional applications that were thousands and thousands of rules, whether it's in insurance or healthcare or in credit cards. And those applications are going to be written in small services. Enterprises are reinventing themselves as micro businesses. And these micro businesses are actually far more valuable than even sometimes the bigger businesses themselves. So I think that's something that we are seeing a lot. Is following the trends, the microservices of software. You get building micro businesses around them. Open source then is another huge phenomenon in software. And in open source, we are seeing the defense of community with product, right? As opposed to defense of the community with just pure philosophy with code. And I think open source has truly made this a pull-based economy, not a push-based economy. How do you it's open source is not just about free, it's about freedom. The freedom to be a software maker, not just software consumer. And I think that's kind of the core theme behind the change we're seeing and how H2O itself has been adopted by thousands of organizations with very little push, a lot of pull. And that's truly because companies want to make software, not just consume it. Becoming consumers to such a powerful phenomenon amidst us is very limiting. So it's a participative environment that lets you be makers, and makers are going to make. That's kind of a core theme you see amongst H2Os as well. It's nurturing community with beautiful product. That's kind of the core end goal of most data science. And data science becoming a software movement means that you can actually now build data products that become APIs, that become applications that users can touch and feel. There's a huge convergence of many fields happening around this time that used to be traditionally competing or even unrelated. You're seeing HR companies trying to work on real estate, prediction of real estate values, to insurance companies trying to make sure employees take regular exercise so they don't get sick. So there's lots of convergence happening around this time, and data is a true horizontal that connects so many different verticals. What's a data product? Some might ask. And it's the heart of data product. Actually, it's of course data, but it's trying to build feedback loops that makes data really shine. How do you create feedback loops in your apps? And of course, algorithms between automatic machine learning, that's a major trend happening in terms of data science refinement to deep learning. We're seeing a lot of real data science improvements from the core platforms. But data and connecting data to users and connecting those user interactions as feedback becomes a real loop that you want to accelerate. It's that loop that's learning continuously. And that's the core. I mean, of course, you couch this data product with an API or a user experience, but that's the heart of a data product. It's the learning rate that defines how fast your application is getting smarter. Before, we were data-driven applications. Now your applications are learning from data. And so you're no longer programming your computer. The computer is learning from data, and I think that's a pretty dramatic difference from how we built applications in the year 2000. Learning, of course, needs a lot of heart. You need love to learn. It's a lot of hard work. Learning is admitting that you did not know something a minute ago. And that's a hard problem, and that takes, again, a lot of human openness to learn new things. An example here is, like, for example, I remember speaking to the author of Moneyball, Michael Lewis, and when Oakland A's, Moneyball, which kind of has a core theme behind how data science became popular in baseball, when he actually was in the locker room of Oakland A's team, he found that nobody was even presentable. None of the players looked great on TV, right? But they were all good at what they were doing very well, individually and together as well. I think data science throws at us analysis that will force us to do things that don't look great on TV or don't look great on traditional metrics of hiring people or adding teams. And I think that's kind of the core theme, is learning takes a lot of courage. Data science, in the truest sense, is actually the search for truth, because you're continuously refining your hypothesis again and again and challenging your own status quo about something. And in many ways, that something is really you, because data is actually a footprint we've left on the universe. The universe, like this auditorium, is very sparse, and it's also very messy. Just like a few minutes ago, nobody could predict that we'll all be out of this auditorium. So data is capturing events in the universe, and so it's both sparse and messy. So it's a very compelling footprint of you in the world. So you're really trying to look at human behavior, at our behavior individually and together, and in conjunction with other events that are kind of really stochastic. And so data science is really trying to get more of a handle on the self. How did we build this thesis around what are the many aspects of the data science part? Well, it starts with data. Data comes in many forms and factors, sparse and messy being the other parts, which we kind of left on the left side of the equation here. But the core to the science of this is algorithms, which is basically speed and accuracy is what we are trying to predict. The accuracy and speed come together in one package, because you want to predict the weather tomorrow's weather today, not the day after. So timing is a core aspect of finding the most accurate prediction. But also there's a bunch of algorithms that have been invented in this space, have been built, some of which H2O has built. Scikit has built a bunch of them. Pandas, the open source communities, the R community, the Spark community, all these communities have been building a lot of good algorithms that can be used on large data sets. And that's kind of the core thesis here, as you keep adding more features. For example, at H2O, we had to rebuild the entire data platform once we crossed the 1,000 feature barrier. At 10,000 feature barrier, we had a more columnar, compressed, variable chunk data structures to take advantage of this sparseness and the more brokenness of the column structure. As you get to 1 million columns, you're really looking at dots, not columns. Looking at graphs, the core data structure had to be reinvented to deal with sparse data. For text and images, of course, deep learning, the game in town is deep learning, which is pure matrix multiplication. And that's where we moved on to GPUs and non-traditional hardware. And I think that's kind of the core ethos of how the whole space has been evolving. But this space is not interesting if it doesn't bring different dimensions, different people, different walks of life to the space, and that's experience. If you can't reach the Excel using data analysts, which is hundreds of millions of people, then you're still not solved the problem. You haven't made it simple yet. So I think the core a large part of H2O inventions that are happening inside the company are towards simplifying the space. How do we make it easy to operationalize it? How do we easy to deploy it? But also, how do you make software designers use data? Software designers use data science and algorithms without having to dramatically alter their application structures. And APIs play a very big role there. Different frameworks for API, different design frameworks, improvements in D3, for example, have brought much more visual interpretation into the core ethos of data science. We'll talk a little bit more about storytelling, because that's such an important aspect of increasing the experience and increasing the bigger number of people you can touch with your data analysis. If people have seen this book, I'm imagining, phenomenal book, definitely worth a read. If I had to pick a small tidbit from it, it would be the APGAR score. Before 1970, a lot of people, actually in the 50s is when APGAR score was actually invented, and it's part of the anecdote from the book. And infant mortality was such rampant because it was very difficult to find midwives who were very well educated, or who could sense when a person when a newborn needs to be taken to given urgent care. So APGAR, a nurse, came up with this simple score, and with just adding those 3 different features, one can make an assessment whether to take the newborn to the doctor urgently or not. And that was a pretty dramatic improvement worldwide. So thinking fast, thinking slow, where someone came up with the learning behind on what are these features, and then came up with a simple way to come up with a score. And that makes a huge difference in changing the world. So learning and scoring are 2 different aspects. Of course, there is online learning, which is truly unsupervised learning. This is another great book I recommend. Score takes care of itself. I'm trying to build teams and how to build really powerful teams that can deliver on results, not just deliver on how individual rock stars are incentivized. I think the growing ethos you'll see is the data is a team sport. In order to get a lot of people to work together, you need to work like as if it's a game that you're planning to win, and together, not just making 1 or 2 of our people heroes. And I think that's the core ethos that this book captures on how to create high-power teams. The power law of networks. If you have one idea, you usually use that as a very common thesis in trying to have round tables as opposed to square tables in offices. Is if you have one idea, you're just rich by one person. If you create an ability for several ideas to be shared within the group, it's a chance to bring infinity of ideas to work in your favor. Because ideas are the map in which you can really look at the world in a very really simplified way. Almost the dimensionality reduction happens because wisdom of many people can be applied on the situation. And I think that we're truly going towards the infinity ideas. Of course, this we talked about earlier. How do you bring user interaction so your data that you started with has now enriched data that you can then serve back as data product. Simple example would be connect an application for end user interaction. Suddenly you have lots of behaviors that you can capture and you start predicting, and then the user is reacting to the prediction. And the power law of networks is both being able to create lots of user interactions so that you can create a very rich data product. This is something that we've learned quite a bit, both as a startup and as small communities. The core theme is to build ecosystems, not just product. Someone was saying earlier today that Hadoop is not just a product, it's an ecosystem. Yes, and Spark is not just a product, an ecosystem. Python is not just a product, it's a huge ecosystem. And I think on the base languages have been built so many newer, richer frameworks that have built even larger ecosystems and larger value has been derived. It's about raising a forest, not just a tree. Data is a team sport, and I think in that is behind that is really how do you bring domain experts to help us look at the right data sets, hopefully curate the right data sets, and bring data scientists to bear through their algorithms to help build really design-rich business applications. I think that's at every junction of that line, and we have had those people with those disciplines work at H2O. At every junction of that line, there is fierce warfare. And this is real warfare. People have a lot of disagreements. The mathematicians don't necessarily have a lot of respect for software engineers, and vice versa. The software engineers don't necessarily have huge respect for the data engineers, and the domain scientists and the business apps. You're trying to bring really very, very different dimensions of work into one small unit. So it's a very violent situation. And the beauty about violence is actually that it does create a lot of innovation. But you need to be able to put a lot of different people together and have them work as a single unit. I think that's a core theme behind data as a team sport. Team sports all are completely learnable, but they're definitely a lot of work. Culture, in this case, is your co-founder. If you can build a culture that really looks for the score, the final end game, and looks at how we can go change things. I think that's the core piece that brings and bonds team sports. At H2O, we looked at this question: why make one CEO when you make 10? And the way really, truly to do that is to expose as much data to the entire team as is available to me. And I think that's something that's very interesting is if you start playing that I want to see the forest for the tree, it's a very different aspect to the overall thesis. Most of our team is exposed to the entire board deck as is, right? Sort of, it's a very, it's compelling to see. It'll be interesting to see how the experiment plays out. One day I woke up with a much more richer dream. Why not change the world with 10 great CEOs who are women? Because changing at the top has a much bigger impact. So H2O is actually about 48% women at this point. We're a small company, but we're still growing in the same structure. And over time, we're building leaders at every level, and we're looking to build some amazing culture there which can bring change in spades. Every generation has to fight its own revolution. And cancer is one of those problems that we see, which is a very powerful data problem. And it's a very, very distributed problem. Networks at work against us and with us. So I think this is one problem that we definitely want to bring a lot of attention from both the math communities, the data communities, and the software engineering communities. 40,000 fMRI studies got invalidated a few months ago because there was a bug in how the software was reading the pictures. That's 20 years of brain research that's no longer valid. So many surgeries, so many analysis that might have to be redone, essentially. I think what was stark facing us is that the software always has bugs. See, and in this particular case, actually, 2 of the softwares that were used were actually open source. But so software always has bugs, and you'll have to rerun your experiments. So science, which is data science, and that data science, by the way, now applies to us. We have industrialized science at this point with data science. And so for us too, if we store the data, if we keep still the data, open data, within the company, open data, and outside the company, open data, I think those are 2 different forms of being able to rerun the experiments to change your hypothesis. I think building open data ecosystems, and specifically in open data diagnostic software, is something we're now beginning to get our hands really into and try to make sure we bring change to places where you can actually have impact on lives. Data products can save lives. I think that's kind of the core piece. And consumers, we are being consumers. We can integrate very diverse verticals and say, this is my data. I want to understand how well I am based on all the data that you guys have collected. Storytelling is one of the last theme I want to bring into this topic. It's such a human endeavor. interpretation is far more valuable sometimes than accuracy. People are going towards gray box models because you can actually interpret them versus purely black box models. And I think that's something that we're trying to put some more visual machine learning aspects into the picture. Here's a very popular example. Of course, you can't end a talk without having the backdrop of the political scene behind us. But I think 538 has definitely done a phenomenal job in trying to put stories together for a large data, sometimes running thousands of simulations, and then coming back with a simple analysis that tells a story. I think visual tools are kind of really powerful for us to understand what's going on at every level. Data journalism and visual intelligence starts where data science ends. When we started 5 years ago, or even 7 years ago, when I was looking at data science as a space, it was a very small space. If you want to acquire the most number of still underappreciated talent in this world, it will be data journalists. 5 years from now, data journalists will be where data scientists are today. And of course, what is a data scientist? Of course, he's obsessed with data. I would say 99% data and 1% story, right? Although I put 100% there. A business unit leader, on the other hand, is looking at 85% data and at least 15% of storytelling. And as you go up the stack, right, executives are mostly storytelling. And I think that's the core theme. And of course, below the board is, of course, grandpa, who's like 100% storytelling, because that's where the grandchild is listening to stories. I think that storytelling aspect is really key to get your analysis be adopted by the community around you. AI is eating software. Software has been eating the world, and end of code has been declared. We did an experiment of using deep learning. One of my team, I don't know if it's in the audience, did deep learning for taking code fragments from our own H2O code and created new code using deep learning. And it was it compiled, and it nearly looked like real human written code. And these are, I mean, of course, we're building test cases, but we're also building algorithms using deep learning. I think the point where AI can write code is not too far out. And I think that's one of the pieces that so far software programmers made a lot of other people jobless. And I think it's about time AI takes sweet revenge and starts writing code. Software that trains itself with data. And that's manufacturing intelligence. Here's another favorite slide of mine, which basically shows that a domestic cat is actually faster than Usain Bolt, right? And a butterfly is actually faster than him as well. What does that say about how come we are leading the world? We're leading the world because of intelligence. So AI is going to be very disruptive. AI is manufacturing intelligence, manufacturing pickling brains of surgeons, of engineers, of different variations of every kind. So AI is going to, if intelligence dominates the world, I actually take offense to the word artificial in AI. There's nothing artificial about it. It's intelligence. I think intelligence is going to be very powerful, and it has the capacity to make us more human by taking away a lot of the drudgery work out of, and also some of the real advanced work out of our hands as well. There's a possibility that it can make us more human beings, of course. It's just a process. The struggle is a story. And I think in that process is how we are discovering ourselves in many ways. And AI would probably be a very powerful companion in understanding the world and understanding ourselves. I'll leave with Eminem. Better lose yourself. This is the time you've got. This is all the time you have on this planet. Thank you.